Everybody take a deep breath. We're past Unit 3 now, and we're heading into the second half of the course, and we've done most of the content now, and we'll look at 3 more units, and some of those will run really fast. So making good progress, and let's keep up the good work. So Unit 4 is all about data, and we'll look at data from many perspectives, from how to process and analyze the data, how to query the data. We'll look at many activities that you can use in your class. Today's lesson, though, is all about big data, which is a recent kind of phenomena that people have been looking at just over the past few years. And you've been given a reading assignment for this, and we'd like you to look at that. And in particular, we'll start talking about why it's important and some of the differences in big data compared to the way we've always done analysis and experimentation, even scientifically in the past. So in big data, the whole idea is about the vast amount of information that's being collected every day. So, this slide here says 2.5 quintillion bytes of data every day. And the slide, the figure to the right is talking about how much in the past 5 years we've collected more data than we've had in the rest of the history of the world. So data is being collected from all different sorts of things, from internet transactions to sensors to media sites. Records of all kinds of sources are being collected from different data sensors and different kinds of interactions. So as these data sets are growing to a very large size, it's becoming very hard to manage. Just the overwhelming nature of all of this. So it's very hard to derive meaning from all of the data. There's no way that a single human can look over the data and make some kind of observation. So the reason this is important is many reasons, mainly because of the way that data is in all kinds of domains and the interesting kind of questions that can be asked across those domains. So from business and retail to sports and finance, we'll see some examples of this throughout this lecture, even in medicine and other things that are important to our health and welfare, from disease control and so on. So from analyzing the big data, we can draw a lot of insight that helps us gain new knowledge about things we may not have known before. So in the article that you looked at, there were 3 V's that were defined. And the 3 V's referred to the volume, variety, and velocity. So volume refers to just the overwhelming amount or size of the data that is being analyzed. Variety is that we're receiving these data sources from many different places in different formats, in different representations and so on. So the variety is coming from social media, from sensors, from other kinds of feeds that we don't have control over, and it's all kind of messy. And then velocity is the sheer speed at which the data is coming from. Imagine analyzing Twitter feeds from the Super Bowl or some other kind of event where there's millions of tweets being done each few minutes, and then combine that with volume, and it's kind of like drinking water from a fire hose. So the sheer velocity, the speed, and the volume, that much coming at you at once, it's not possible humanly to process that, and even past techniques are not very good at processing that. So big data and its new analytical capabilities is addressing the challenges it's faced from the properties shown here on these 3 V's. So it's a very interesting paper to read. It's very accessible. There's not a lot of technology or terminology there that's beyond understanding from a first level teacher for CS principles. But there's some really interesting stories and background and motivation. So it's a great paper. We encourage you to look at that. So the paper also identifies several emerging trends and some of the unique things about big data. So one thing that the paper points out is the datafication of things. So every activity, every event, there's some kind of sensor or it's being recorded. Social media, the idea of crowdsourcing and human computation we'll talk about in a future slide. But everybody has a camera now on their phone, and everyone's taking pictures of everything, or there's sensors all over the place in places we don't know, or cameras. So it's this idea of turning all of our activities in daily life into data, and sometimes the data that's being captured, we don't even know what we're going to use it for. We're just capturing it for the sake of capturing it, and later on down the line there may be some really interesting kind of use. So the unanticipated use of data is also very interesting to explore. And so this has all changed how we approach data. So again, we're collecting very large volumes of data. Rather than in typical scientific experiments, we might actually have very small numbers of samples, but we have to make sure that those samples are very pure and pristine, where with big data, it's okay to have a few outliers or a few things that are not totally in line with the rest of the data, but the sheer volume of it, the data itself will take over and correct some of those. So also the benefits of using the data outweigh, the volume of the data outweigh that. And the interesting discussion or difference between correlation versus causation is seen when we look at big data. So correlation rather than causation is necessary because we don't really take the idea of big data as informing us about why things happened, but rather than the what. So we can observe that some phenomena occurs in this data. We don't know why it occurs, so it's probably not correct to imply some kind of causation, but there is a correlation that we can observe, and we can see there's some kind of trend here and later investigate why. And this paper also points out the continuing need for human intuition, because sometimes we have to provide that insight that the data itself needs in order to be able to make that next breakthrough or next discovery. So as we said earlier, big data can be applied to many different domains, and there's lots of examples in the way that it can be used. You can find these actually often in the tech news. So ACM Tech News is a great source that will have examples of big data usage and big data breakthroughs. Some examples commercially were Netflix and Amazon, how they can use big data to improve recommendations. In fact, Netflix had a competition where those who had a better algorithm for computing recommendations based upon past views of movies would win a sizable cash prize. Other examples include in education here in Alabama, Mobile County actually was able to increase the graduation rate by 15% by using big data and finding out reasons why students may be missing classes or otherwise not completing their coursework. Another example here on this screen is Domino's used big data to figure out that customers order much more pizzas when it's raining outside. So companies can target their marketing and their ad campaigns around weather patterns in this case. So to continue this, also how it's used, there's some examples to discuss how medical needs can be met with complex genome analysis that allows customized treatment of cancer patients. There was an interesting example a year or two ago from the Google flu trend, where it could predict where flu outbreaks would be. So it was predicting flu epidemics much more quickly than the CDC could predict them. Eventually there were some flaws found in that, but then they corrected that and continuing now to be able to predict where flu epidemics would occur, or other kinds of analysis of social media where again the volume and the speed of that data is coming in many different ways. So big data can also help police predict where crime might be occurring. So the kind of Orwellian big brother kind of viewpoint. And other kind of examples you'll see here. So moving over to an example from some sports, you may remember the movie Moneyball that was out from a few years ago. And so if you can imagine all the different kind of statistics that are collected in athletics, and particularly baseball, so all the different trends among pitchers and batters and combinations in all different kind of settings. So this is much more information than a manager can have in their head, even though they have strong intuition. So Moneyball was all about how the Oakland A's were able to use big data and be more competitive than teams that had 3 times their salary, just by being able to look at the trends and analysis of certain situations that their players may be in. So that's just an example of big data even in sports. So the way that we process big data, and we'll cover this more when we look at the performance tasks a little bit later, but there's 6 steps that are described here. So the first thing is to identify a useful data source. Where's the information coming from? And what kind of questions can we form from that data source? That's a very important step that sometimes in CS Principles our students will find as a hurdle and a challenge. So we'll talk about that in a future unit where we discuss the topic of performance tasks and the investigate performance task. So after we have identified the data source and the questions we want to ask on that, We then need to extract the data into a format that we can use with our tools. So as we said, the data may be messy in all kinds of different forms, and we have to bring that data into a form that we can use. We have to normalize that data. So the idea of normalization is removing redundancies and a lot of irrelevant details that we don't need, so that we can get right to the point of the essence of the data that we want to look at. And then once we've normalized and extracted it, we want to import that into some tool that will help us with our analysis. Actually perform the analysis is the goal, and then visualize results. So this sixth point of visualizing results we'll actually talk about a little bit later as well. So there's various tools that can be used. By far the most used tool in CS Principal is Microsoft Excel. We hope to show you a few more things that can be used, in particular with Google Docs spreadsheets, that might be of assistance to you and your students when you work through the CS Principles course. Other tools that you use professionally might be beyond the grasp of some of the students in CS Principles. For example, Hadoop and SAS are actually more commercial-based things that are used. So there's also other things from Google, the prediction API. Michelle Roberts will mention a few other tools as well. So there's all these tools that are available. In general, students pretty much default to using Excel or some kind of spreadsheet or local database that's available on their machine. There's also a chance to talk about ethics within CS Principles. So you may want to think about the ethical issues of collecting data at such a large scale from people, and they may not even know about it. And there's been all kind of discussions in the media about this. You'll find articles in tech news throughout the next year that will certainly emerge from this. So it's a great point to combine the discussion of social media and ethical concerns with this notion of big data. So big data allows corporations to collect this large amount of information about their customers. There's issues of privacy. So when we discuss the internet in conjunction with big data topics, we could ethically look at these ethical issues on selling information from companies to other agencies, and those types of issues would emerge. There's also examples of big data gone wrong. So there's a very famous example from Target, where Target was sending maternity clothes and baby clothes coupons to a teenager, and the father reacted, and it turned out the daughter was pregnant without their knowledge. That's a very well-known example. There's other examples that are shown here on this screen where companies became kind of involved in litigation because of ways that big data was used for collecting information, and it resulted in lawsuits. So you can read about some of these examples here. These are just from the past year or two. And as I mentioned, you'll certainly find things like this emerge in tech news, and other even traditional media will comment on these things from time to time. So there's an activity you can do with your students that's a lot of fun. So if you go to this website, the Akinator, it's kind of this, ask me 7 or 10 questions and I'll be able to predict what you're thinking of type of game. And so if you enter your age and your name and you think of a certain character or event, this particular web page, after asking a few questions, can narrow down and isolate what it is you were thinking of. So what we like to ask the students is to think about, how does this actually work under the hood? So obviously this web page has at its own access a search engine with all the information on the web available. But this particular tool will even bring up a picture. For example, if I were to think of Mickey Mouse, after a few questions, this tool will be able to guess Mickey Mouse and bring up a picture of Mickey Mouse. So the question is, how does this work? And there's a lot of information available on the web. So in some sense, this isn't totally big data, but it kind of gets to the idea of having a large data source and how we can narrow that down to find answers given a set of questions. So the rest of this unit, we have several other activities planned for you. In the next lesson, we'll look at the structured query language and apply that to Google Docs spreadsheets. We'll also look at pivot tables. And then you're really in for a treat with Michelle Roberts. She has several activities planned for you that you can use in your own course. And I think you're going to really love these. So please stay tuned for that. I think some of the work that Michelle's done is going to be an example of what many CS Principles teachers will start adopting, because there's really a lack of information on data and curricula for data, and that's one of the common things that teachers are asking for. So Michelle's work coming up in just a few more lessons will be a deep resource for you. And then we'll have our break. We'll have a 2-week break. We'll give you a few things to work on, but when we come back, we will show you what we discussed live in our professional development at the University of Alabama with our Alabama teachers, and we'll talk about the investigative performance task. And in that context, we'll share with you some sources for where students can find data. We'll give you some examples of past student work so you can see what kind of questions and data sources students were using in other past performance tasks. And we'll also discuss the topic of visualization. So stay tuned. We have a lot planned for you, and see you at the next lesson.